Good morning, everyone. This is Akanksha Patel presenting you the topic Performance Analysis of Hybrid Optical Amplifier. So, before entering the depth of the topic, let's first discuss in brief that what is an optical fiber. An optical fiber is a flexible glass or plastic structure which can carry light or information over a longer distance. Optical fiber has a transparent core as you can see in this particular diagram with a refractive index of N1 and transparent cladding of refractive index N2. So the refractive index of transparent core N1 is greater than the refractive index of transparent cladding, that is N2. Then the cladding is in turn surrounded by a protective jacket. So optical fiber has a low loss transmission, as here the light guided mechanism is total internal reflection. So it has a wide usage in case of medical fields, as you can see over here, and that is endoscopy, bronchoscope, ultrasound, in civil and construction field, in chemical and biomolecule sensing, temperature and pressure sensing, military and satellite communication. Now let's discuss about the optical amplifiers. So as the signal has to transmit through a longer distance, it gets weak and distorted. So it becomes difficult in the receiver side to detect it. So for that reason, optical amplifiers are used to boost up the intensity of the optical signal so that they can transmit and detect it smoothly in the receiver side. So the two most important groups of optical amplifiers are semiconductor optical laser type amplification and another one is fiber type amplifiers. So what is a semiconductor optical laser type amplification? So what is a laser first of all? Laser is a light amplification by using stimulated emission of radiation. So these are based on a conventional laser structure. Here, the light amplification is done through a laser. That is, light amplification is done through the stimulated emission. Now, what is stimulated emission? An incident photon energy induced transition from upper energy state E2 to lower energy state E1, that is known as the stimulated emission. So here what is happening, here it can operate at a wavelength of 850 nanometer, 1310 nanometer, then that is 1550 nanometer. But then it has a drawback that they can only operate at single wavelength or channel. So for that reason here, the laser, besides amplification, it can also undergo wavelength conversion. It can convert the wavelength that is high photon energy to longer wavelength of low photon energy. Then let's go to fiber type amplifiers. It is broadly classified as Erbium Dopped Fiber Amplifier EDFA and Praseodymium Dopped Fiber Amplifier PDFA. So when we talk about EDFA, these are widely used because it has DWDM, that is dense wavelength division multiplexing technique, which allows multiple wavelengths applied to transmit through a same medium. Here what is happening, that is EDFA can operate at a wavelength of 1530 nanometer. It has a high gain and it is an optical repeater device which can be used in optical fiber communication system. It is doped with the rare earth material, that is erbium, so that the glass fiber can absorb light at one frequency and emit light at another frequency. Then we have praseodymium doped fiber amplifier. Here it can operate at 1300 nanometer band. But here what is happening is that here the optical gain is very less, and another problem which is associated with it is a non-radiative recombination process, and this particular problem can be solved by replacing the silica by fluorozirconate. What is it? Fluorozirconate ZbLAN glass fiber. So, PDFA has a minimum use in optical fiber communication system. After PDFA, you can see over here a particular diagram, but before that a small description that the combination of more than one optical amplifier is known as hybrid optical amplifier. So when we talk about hybrid optical amplifier, the first thing which comes into the mind is the combination of EDFA and Raman amplifier, which is the best choice. When we talk about Raman amplifier, now what is it? It uses SRS. Now what is SRS? SRS means stimulated Raman scattering in the optical fiber, which transfers the energy from high frequency pump signal to low frequency pump signal. Okay, so when we talk about, so the combination of EDFA and Raman amplifier has a very high gain, and that is the best choice as a hybrid optical amplifier. As you can see over here, the gain profile of hybrid optical amplifier. Now let's go to this particular simulation model, which is the main part of my analysis. So here the basic configuration of hybrid optical amplifier consists of 16 channels with 50 Hz of channel spacing. So here, as you can see over here, a WDM, that is wavelength division multiplexer system, is placed over here, and all the channels transmit through the WDM, with the first channel at 193.5 THz, and the input power of WDM is 20 decibel meter. So here what is happening? Here all the channels transmit through the WDM, that means the combination of light signals. They transmit through EDFA, which is of length 9 meter, counter pumped at 1480 nanometer, and that is here what is happening, the pump power is 130 megawatt. Then the output of EDFA passes through optical isolator, and this particular optical isolator here, it protects the system from the back reflections. The output of optical isolator passes through Raman amplifier, which is of length 11 meter, counter pumped at 1450 nanometer, 1452 nanometer, 1454 nanometer and 1456 nanometer with a pump power of 450 megawatt. So now this output of Raman amplifier, which is the overall amplifier signal, it passes through the optical spectrum analyzer in order to analyze the optical spectrum. So the dual port WDM analyzer is present just after the Raman amplifier in order to calculate the values of gain and noise figure variations. Then it passes through the photodetector so that the optical signal is converted to electrical signal, and after that the bit error rate is minimized, because the means low is the bit error rate, the good is the quality of the communication system. So this bit error rate is minimized up to, that is, it should be less than 10 to the power minus 6 dB. So this was about the simulation model. So from this simulation model, what we obtained is this particular graph. Now what do we observe from this particular graph is that here the EDFA and Raman amplifier both individually were absorbed as inline amplifiers. So EDFA amplification is 13 decibel. And here the gain is not uniform and noise figure variation is 13 decibel. But in case of the Raman amplifier, amplification is 10 decibel and the gain is flattened and the noise figure is 6 decibel. So as you can see in this both graph, the output power spectrum is represented in red color and the noise spectrum is represented in green color. Then next we have, so now when the hybrid optical amplifier is placed in a network system, then what is happening then here it has a very increase in gain. Why it has a very increase in gain? Because of the combination of EDFA and Raman amplifier. As you can see here, the gain is taken as a function of frequency. Here it varies from, it has a range of 12.41 decibel to 16.21 decibel. So here what is happening, it's a flattened gain response. And this is a graph for the noise figure, which is taken as function of frequency, and it is of range 6 decibel. So here from here we can say that EDFA has a very high gain and it can be used for long distance communication. By the combination of EDFA and Raman amplifier, hybrid optical amplifier has increased gain up to 15 decibel. Then the gain variation is reduced up to 2.7 decibel and noise figure variation is below 6 decibel. So here I have used 16 channels, but more than 16 channels with reduced channel spacing can also be used by incorporating more processing units, by incorporating more pumping schemes, pump power. The performance can be enhanced and we can obtain an excellent quality of optical fiber communication system. So this was all about my analysis regarding the performance of hybrid optical amplifier.